Scientists studying Mars have identified a broad, flat band of terrain that resembles the ring left behind when a bathtub drains. The feature, described as a coastal shelf, stretches for hundreds of kilometers along the planet's northern lowlands and could be the imprint of an ocean that covered roughly 1/3 of the red world billions of years ago. Researchers from Caltech and the University of Texas used computer models to simulate how Earth's continental shelves persist after oceans recede, then examined data from the Mars Orbiter Laser Altimeter to locate a comparable structure on Mars. The shelf is about 200 to 400 meters wide, far larger than the narrow shoreline traces first reported by Viking missions in the 1970s, and its size would have helped it survive erosion over geological time. The team argues that rivers once poured sediment into this ocean, building up the shelf much as Earth's rivers feed continental margins. Supporting evidence comes from the Chinese Zhurong rover, which found ancient beach deposits in the same region, and from the Perseverance rover's discovery of layered sediments that suggest long-lasting water activity. While Mars still retains water ice at its poles and possibly sizable underground reservoirs, most of its early water was lost as the thin atmosphere allowed it to escape to space. Estimates now place the disappearance of surface water as late as 2 billion years ago, far more recent than earlier models. The finding fuels a long-standing debate about whether Mars ever had a global ocean, a question that matters for understanding the planet's climate history and its potential to have supported life. Critics note that Mars lacks plate tectonics, a key driver of Earth's continental shelves, and that differences in tides and currents could produce a different geological signature. Nonetheless, the proposed shelf offers a testable hypothesis. The upcoming ESA ExoMars rover, Rosalind Franklin, slated for a 2030 landing, will be equipped to analyze the mineral composition of this region, both on the surface and below it, potentially confirming or refuting the ocean hypothesis. Confirmation would reshape our picture of early Mars, suggesting a warmer, wetter world that may have been hospitable to life. The research published in Nature adds a new piece to the puzzle of Martian water, but the scientific community stresses that more data are needed to resolve the mystery of where the water came from and where it ultimately went. The ongoing exploration of Mars continues to reveal surprises, and this latest clue brings us one step closer to answering whether the red planet once held oceans like those on Earth. The latest news you find here.